Hello guys, just hope everybody is doing great. Okay, this is the second part of the video I started but has not finished. Since I told you guys earlier that I has not finished, I will not finish it in the first video because in fact the video will be too long. Yes, and I don't want it to be too long, so that's why I decided to separate them. Now we continue solving the GCE 2024 question 6 advanced level mathematics. Okay, we ended on question C. Now we'll continue from D in this video. Now question D says show that the x coordinate of the point C is 1. Now let us analyze it very well. We are asked to show that the x coordinate of the point C is 1. This is our point C here. Now what do you realize here? You realize that at this point C, at the point C, the x coordinate of the graph, that's where the line ED and the curve, where they intersect at point C. So at this point C here, the x coordinate of the graph is equal to the x coordinate of this line. Yes, I think I'm making myself clear. The x coordinate of this graph of this curve is equal to the x coordinate of this line here, or the y coordinate of the curve is equal to the y coordinate of the line. Now in our previous video, we saw that the equation of the line was given to be x plus y is equals to 5. That's the answer we had for the equation of the line passing through ED. And also we had the equation of the curve was given to be y is equals to 2x into 3 minus x. This one is for the line, this one is for the curve. Okay, now the D part says show that the x coordinate of the point C is 1. That's D. Okay, for us to show that, as I earlier said, it's either we see the y coordinate of the curve equals the y coordinate of the line, or the x coordinate of the curve equals the x coordinate of the line. But since we are asked to show that the x coordinate of the point C is 1, that means we are trying to eliminate y. Yes, so we can make y the subject formula in either of the equation, but I think it will be more simpler for us to make y the subject formula in equation 1, so that we can chuck it in, so that we can substitute in equation 2. Sorry. Okay, so we have from this equation of the line, we realize that y is equals to 5 minus x. Yes, so we are going to substitute it in the equation of the curve. Okay, it will mean that 5 minus x is equals to 2x into 3 minus x. Okay, from there now, 5 minus x is equals to 2x times 3, 6x, 2x times negative x minus 2x squared. Okay, we bring like items together, realize that 2x squared, now when 6x comes, it becomes negative 6x. Negative 6x minus x minus 7x plus 5 is equals to 0. Now we are having the quadratic to solve for x. Now we are looking for two factors. That way we multiply, we have AC, that's 2 times 5, that's 10. And when we add them, we have negative 7. Two numbers that we multiply, we have 10, and we add, it gives negative 7. Okay, we have the number 2 and 5. Now what is 2 times 5? 2 times 5 is 10, 2 plus 5 is not, so I can just add a negative there. Negative 2 times negative 5 is 10, yes, and negative 2 plus negative 5 is negative 7. So the factors are So the numbers are -2 and -5. Okay, perfect. So this equation becomes 2x squared minus 2x minus 5x plus 5 equals to 0. From there we can factor out 2x here. We have 2x into x minus 1 is, and here we must also have x minus 1. Then we now attach the factor which is the coefficient which is -5 is equals to 0. So we have 2x minus 5 and x minus 1 is equals to 0. So it is either 2x minus 5 is equals to 0 or x minus 1 is equals to 0. From there now we see that 2x is equals to 5 or x is equals to 1. From there now x is equals to 5 on 2 or x is equals to 1. Okay, we are going to analyze these two answers together. We have the value x equals to 5 on 2 and x equals 1. That's the point where the graph and the line meet. Now between 5 and 2 and 1, which one is greater? It's obvious that 5 divided by 2 is greater than 1. Yes. So it will mean that, let us go back to our curve. It will mean that 5 on 2 is the x-axis. The x coordinate of this point of the point D. And that's really proof what we had in our previous answer, because I can clearly remember that where we were asked to show that the value of k was 5 on 2, and these are we still solve using another method and we still had 5 on 2. Okay, now you realize that the other value of x equals 1 is the x coordinate of this point here, C. So we have shown that the x coordinate of the point C is equals to 1 as required. Perfect. Okay, the next part of the question, that's the last part, E. E says calculate the area of the region bounded by the curve y equals 2x into 3 minus x and the line DE. Okay, I also calculate the area of the area bounded by region R. And from our graph, we realize that this is the region R here. Yeah, yes. So we are also calculate the area of this region here bounded by the region R, because this is the region R here. Now we are going to do some small gymnastics here. Okay, for us to calculate the area of region R, this region R, we will have to calculate the area of the entire curve minus this other side here, that's minus the position OCDB, to have the area of the region R. I don't know whether I'm making myself clear. To have this area, we take the area of the whole curve minus the area of this region here. Okay, let's get started by calculating the area of the whole curve. Now, to calculate the area of this whole curve here, you know that the curve is starting from O to B, and the x coordinate of the point B was 3. That means we are going to integrate from 0 to 3 to have the area of this curve. Okay, so we start. Area of curve be equals to the integral from 0 to 3 of y dx. And now the area can be a, that's a is equals to the integral from 0 to 3 of y. Who is y? Y is equals to, that's the curve, 2x into 3 minus x dx. This is equals to the integral from 0 to 3 of 6x minus 2x squared dx. Now let me come here. E is equals to the integral from 0 to 3 of 6x dx minus the integral from 0 to 3 of 2x squared dx. Okay, which is equals to, now if you integrate 6x, that's x raised to the power 1, we're going to have 6x squared divided by 1 plus 1. That's the loss of integration, 6x squared divided by 2, which goes from 0 to 3 minus, if you integrate 2x squared, we're going to have 2x cubed divided by 3, that's 2 third x to the power 3, which goes from 0 to 3. Now the upper bound here is 3x squared. This is 3x squared. Now upper boundary, when we substitute 3 squared is 9. Lower boundary, any number times 0 will still remain 0. That's minus 0. Now minus 2 third. Now 3 raised to the power 3, that should be 27. Okay, so we have 27 minus 27 divided by 3, that's 9. The 9 times 2 is 18. 18. So the area will be 27 minus 18 will be 9. This 9 units. So this is the area of the curve. The area of the curve. Okay. Okay, now we are going to do some gymnastics here. Yes. For us to calculate the area of this region here, I'm going to divide this region into small segments so that it's going to ease our work to calculate. So the first statement will be something. Okay, as I was saying, let me explain what I did. I divided this this region into small portions. I can call this one P, this one Q, this one L, and this one S. Now, how do I manage to know that this point here is 1? We calculated earlier that the x coordinate of this point C was 1. So when you separate down, here should be 1. That means distance from here, from 0 to here is 1. Here 5.2. Why? Because the x coordinate of this point D here was 5.2. So when you separate down, you have 5.2 here. It will mean that the distance from here to here is 5.2, not the distance from here to here. No. Now, so the distance from here to here, we just take 5.2 minus 1. That should be 3.2. Okay. Now, and here I had 3. That's the x coordinate of the point B was 3. So that's why I had 3. That means distance from here to here was 3. So I will go further to calculate the area of these individual shapes. Okay, now here I will consider this portion to be a triangle. Yes. This one is a rectangle. Another triangle and another triangle here. So now the area. Let me just see area of portion P. That's area of P. Since it is triangle, it will be half base. The base, that this base here. The base here was 1. That's half times 1. And the height. And height is the distance from here to here. Now to calculate the height here, We know very well that the x coordinate is 1. So to have this height, we're going to substitute 1 here. So to have the corresponding value of y. That's the y coordinate. Okay, if you do that, we have okay. Let me just do it here somewhere in my rough work. We know that y is equals to 2x into 3 minus x. Now when x equals to 1, when x is 1, x equals 1, realize that my y becomes 2 into 1 into 3 minus 1, which is equals to 2. 3 minus 1 is 2, that's 2 into 2, which is equals to 4. It will mean that the height from E to C is 4. Okay, times height, which is 4. So the area of figure P, or the region P, will simply be 2 units. Now, area of which region again? Region Q. Same thing. It's equals to half the base. Now, the base is from E to this point here. Hope you're understanding. That means the distance from here to here. And so the distance from here to here, I will take 5 on 2. That's 2.5 minus 1. That should be 3 on 2. That's 1.5. 3 on 2, yes. So I have 3 on 2. Now the height. The height is the distance from here to here. Okay. Now we know fully so well that the distance from here to here, because the y coordinate of the point D was kk. I mean, it was k. That's 5 on 2. That's when we calculated, we had 5 on 2. 5 on 2 is approximately the same as 2.5. We know that the distance from here to here is 2.5. And we know the distance from here to here, which is 4. So if from here to here is 4 and from here to here is 2.5, you mean that from here to here will be 4 minus 2.5. That's 1.5. Correct. Okay, 1.5 is the same as 3 on 2. That's half base times height, which is equals to, this is 9. 2 times 2 on 8 units. Okay, now let us go further and calculate the area of S. Let us finish the triangles. Area of S. Now, the same thing. Area of S will be equals to half the base. Now here is 3 and here is 5 on 2. 3 minus 5 on 2, that's half times height. And the height from here to here is 5 on 2. 5 on 2, which is equals to 5 on 8 units. Now, last one, the area of L. Area of L is equals to, now L is a rectangle, so that will be length times width. Now the length is this is 2.5, and this one is 5 on 2 minus 1. 5 on 2 minus 1. Okay, I'm sorry for the delay. 5 on 2 minus 1, that's 2.5 minus 1 is 1.5. You mean that the width is 1.5 and the length is 2.5. So length times width, that's 3 on 2. I mean, this is the width times 5 on 2, the length, which is equals to 15 on 4 unit. Normally it's supposed to be square unit everywhere. Square unit everywhere. Okay, now to have the total area of this region, so we're going to add area will be equals to 9 on 8 plus 5 on 8 plus 15 on 4 plus 2. Okay, let us do it correctly with the calculator. Okay, we have 9 on 8 plus 5 on 8 plus 15 on 4 plus 2. That's 7.5. 15 on 2 equals to 15 on 2. So, as I was saying, it will mean that the area of the region R will be equals to the total area, this guy, minus this area here. So, area of R will be equals to 9 minus 15 on 2, which is equals to 3 on 2 squared unit. So area of the region R is 15 on 2 square unit. Okay, now we have come to an end, and I hope all my explanation were clear. So if you have any question, please feel free to ask on the comment section. Thank you for watching, and please, I almost forgot, make sure you like, subscribe and comment. See you in the next video. Thank you. Bye bye.